Okay, for our last example, there is a lot going on here, but stick with me because this is actually a really, really practical application of vectors and why they're really important. So we have an airplane that's traveling at a speed of 500 miles per hour with a bearing of 330 degrees at a fixed altitude, so it's not going up or down, and there's no wind. Then it reaches a certain point and it does encounter a wind. The wind has a velocity of 70 miles per hour, so it's pretty strong, in the direction north 45 degrees east. So this is going to have an effect on the plane. Okay, the plane's heading one direction at a certain speed, is countering the strong wind, and if the pilot doesn't adjust, it's going to change some stuff. So we want to know what is the resultant speed, not sped. Let's try that again. Okay, we want to know what's the resultant speed and direction of the airplane. There is a picture of this in your book on page 586. I will do my best to recreate it in all of its glory. So let's start out. I already forgot what it was. Airplane is traveling with a bearing of 500 miles, bearing 330 degrees. Okay. So our airplane, 500 miles per hour at a bearing of 330. Remember, airplane bearings are from the north. So this guy is all the way around here, okay, at 500 miles per hour. I'm not going to write miles per hour, I don't remember. Okay, so if this is 330 all the way around, then this little part right here is 30 degrees. Now, in order for us to use our trig calculations with our vectors, we need to measure from here, okay? So if this little part is 30 degrees, of course we've got another 90, so this is 120 degrees. So if we want to write a vector just for the airplane, okay, so this is airplane only, I'm going to call that vector 1. It's going to be 500, that's its magnitude, and then its horizontal direction is going to be cosine of 120, its directional angle. Sine 120 will be its vertical. Okay, and that's from that formula from the previous page that we get that. But our magnitude and then our horizontal and vertical components are based on our directional angle. Now, I want to evaluate this, but these are special right triangles. I can get exact values on this, which I want because I'm going to be doing calculations on this. So cosine of 120 is negative half, and sine of 120 is root 3 over 2. You can verify that by using your special right triangles. And now I'm going to multiply both of these by 500. So I get negative 250, and 500 divided by 2 is 250, and then root 3. Okay? And I want to leave those exact values. So this is the vector that's describing the airplane. Now, it encounters some wind. The wind is going from the north 45 degrees east. Okay, so we could translate that down here if we wanted to. It's the same thing. So our wind only, if we want to write a vector describing that, I'm going to call it V2. It has a magnitude of 70, with 70 mile per hour wind, and it's a 45 degree angle. So cosine 45, sine 45. Again, I want exact values because I need to do calculations with these. So this is root 2 over 2 and root 2 over 2. So my wind is 35 root 2, 35 root 2. Okay, so what's happening is we have the plane and the wind, and as the wind pushes it, we get a new resulting vector, this purple one. Okay, we need to find out what its speed and direction is because the wind has pushed our airplane slightly off course and probably changed its speed. So our new path is going to be what was originally happening with just the plane, V1, plus what's happening with the wind, V2. So V1 is our negative 250 root 3. And V2 is our 35 root 2, 35 root 2. Okay, obviously at this point we need to go to calculators. I'm going to call my new one just V. Is that okay? I'm okay with that. Okay, so in my calculator I'm going to do negative 250 plus 35 root 2. When I put that all in, I get negative 200.5. And then 250 root 3 plus 35 root 2, I get 482.5. Okay, so this is the new vector that the airplane is traveling. So again, that would describe here and here on this new vector. We want to know its new speed. Well, the speed is just going to be the magnitude of that new vector. So if we come down here, just scroll. So our speed, oh, who cannot spell speed today? Good grief. So the magnitude of V. So it's just the distance formula, negative 200.5 squared plus 482.5 squared. And our new speed, when we put this all into the calculator, I get 522.5 miles per hour. Okay, so originally the airplane was going 500 miles per hour. It's got this kind of crosswind that it's hit, and it's actually caused the plane to speed up a little bit. Now, remember from our picture is we are also heading in a new angle. So we need to figure that angle out. Now, we can do it from this triangle. This is negative 200.5 and 482.5, and we're looking for that angle here. Okay, so we get the tangent of theta is 482.5 over negative 200.5. Notice that is also tangent theta equals b over a, the formula from the front side we talked about. So inverse tangent, let's see, what does our calculator tell us? 482.5 divided by negative 200.5. Inverse tangent of that, and my calculator tells me negative 67.4. Okay, so obviously my calculator is giving me the angle over here, which I can translate that, that's no big deal. 67.4 right here is that angle. This is a disaster. Oh my goodness. I'm going to draw a new issue. So what did we say? 67.4. Let me draw this again so you can see a cleaner picture of what's happening. Okay, so we've got this new path that we're on, and this is 67.4 degrees measured from there. We are traveling in an airplane. So we need to measure from north all the way around, okay, in order to give our new direction, our new bearing. So this portion of it is 67.4. From here to here, that's 270, right? 90, 180, 270. So we're going to take 270 plus the 67.4, and that gives us our actual bearing of 337.4 degrees. Okay, so remember the plane was originally flying with a bearing of 330. It's encountered this crosswind, which is blowing it off course and a little bit faster than it was going. So in order to maintain their same course, the pilot's going to have to make some adjustments to that. Hopefully that all makes sense. If not, feel free to watch these again, and we can also go over questions tomorrow in class.